bringing this event to Delhi. Unfortunately, parallelly, that's what I was telling, several other programs are running, which is again focused on power sector and with government agencies. So, although we expected a larger room full of people, but the audience got divided. But it's not the number; it's the quality of people which are very important. And what comes out of the deliberations, how the government will respond to the recommendations is what is more important than Rajesh sir. Sure that you will be able to, whatever the consensus deliberations will be able to submit to the government, and we'll see that on the policy side we move forward. As all of you know, at Copenhagen in 2009, Government of India made a voluntary commitment, a non-binding voluntary commitment that emission reduction will reduce by 20 to 25% by 2020. So in order to achieve that, 2010 onwards, several national missions were launched. One of the very important one which all of you know about is the Jawaharlal Nehru National Solar Mission with a target of 20,000 megawatt of grid-connected solar power by 2020. So this program, initially it went very well. In between years there was foreign exchange problems, so there was a dip in the annual capacity added to that, but it's again picking up. And several other national missions. I won't get into the details of that. So, energy efficiency is one of the major pillar of that emission reduction. And this topic, coupled along with smart cities and smart grid, is a very interesting concept, and it's all intertwined actually. So, ahead of COP21 Paris, Government of India in October, first week of this month, released the targets. It says 30% of the electricity by 2030 will be coming from renewables. Today, in terms of kilowatt hour, we are not even 6 or 7%, and in capacity it's about 15 or 15%. It's a huge task. Just 15 years taking it to 30%. There is something similar to what California has just done. In 2009, California had come out with an energy policy which said that by 2020 they will do 33% of energy from renewables. And last month they came out with a new policy which says that by 2030 they will do 50%. So and that 30%, almost 25, 26 they have already achieved. The target is 2020, 33%. They have already done more than 25 now. And taking it to 50%. There are many challenges to that. We'll come to that. And India's three commitment: one, emission reduction by 35% by 2030. That 20 to 25 we are now making a firm commitment of 35%, and another 20,000 megawatt of energy efficiency. That's something which the Government of India committed early this year. So a megawatt, 20,000 megawatt of megawatt is the power sector. That's again a huge target. And we will talk about the program which ESL is pursuing. Until last year, a LED bulb used to be something around 172 rupees or something. So when government, as a policy, started procurement in millions, it has come down to 71 or 72 rupees. And from 6 or 7 watt, it has gone to 2 watt more luminous. And price came down by almost 100 rupees in less than 1 year. This is when big governments take action. That's why, like Rajas have been always a champion of policy. We need to have policy intervention. Otherwise, the market will never adjust. If we leave to the market, economists say market will find its equilibrium. But in today's world, big countries like India, China, when at policy level we make decisions, industry will immediately align to that. So yesterday, stakeholder consultation on energy efficiency, building efficiency in the new energy policy which Niti Aayog or the S2L Planning Commission is coordinating with different stakeholders. One thing, great opportunity for India is that it is calculated that we will have something like 2030, the number which I actually seen is 2032. India will have something like 2 billion square meters of commercial space. Today we have only somewhere 650 million square meter. which means almost 2.5 times more commercial space need to be built. And the existing buildings, the buildings which have been constructed in Europe and America, particularly North America, if you take existing hotels, five-star hotels, big government buildings are all consume more than 200 units per square meter per year. And there are designs which today can bring that down below 50. And we have several standards in the discussions with Smart City Dialogue in DMIC. They have done a very good job on this. So many places, there are many designs which are coming to be somewhere around 70, 80. So every discussion I say, make it mandatory. Don't give a high target of 50. At least let's make it below 100, below 70. These are commercially available technologies. If we mandate commercially available technologies which are already priced, the return on those investments are 2 years. When I say it is already price competitive with other options which are available. If you make it mandatory, no permission will be given unless per square meter energy consumption per year is less than 100 or some basis. She will be talking more about it. He's an expert on that. So on the smart side, 10 years ago, 8 years ago, when I used to go to conferences and talk about smart grid, people used to ask why India need a smart grid. These are all companies are trying to sell all products here. We don't need. We have to find solution for giving access to electricity for all the people. We have 300 million people or 80, 90 million households which are not connected to the grid. We should do the same model of electrification to give access to electricity to all the people, and later we'll talk about making it smarter. But we can. Now people are convinced that, including policymakers too. When we talk in large conferences, nobody asks this question, why do we need it? People have seen how technology evolutions we can leapfrog and make things work at the same time at marginal cost. In last 5 to 6 years, if you look at it, more and more the generation resources are getting connected at the distribution end in many geographies, particularly in developed countries. More generation capacity connected at the low voltage distribution end of the grid, which is changing the way the electric grid is engineered, built and operated for about over a century. We have huge power plants which are injecting electricity into the grid, and high voltage lines taking it to massive large geographical area, stepping down and supplying electricity to people here. So millions of people drawing electricity from the grid and few large power plants injecting electricity into the grid. That landscape is changing, and this is changing very fast. Many places it has already changed. When I said California, there are millions of bombs which are actually injecting electricity back into the grid. So a grid which is built for one-way flow of electricity, which we operated that way, is on a sudden becoming witnessing two-way flow of electricity. India also, the target of JNNSM, the 20 gigawatt by 2020, which we originally started it. Now the government came out with new policy this year, 5 times more, 100,000 megawatt of solar, grid-connected solar energy by 2022. Only 2 years they have extended, but the target has gone up by 5 times. And in addition to that, another 60,000 megawatt wind and 15,000 other miscellaneous biomass, etc. Out of 100,000 megawatt of solar capacity planned for next 7 years, 40,000 is envisaged to come from about 2 crore rooftops. They have given the year-wise target for each of the states, how many megawatt from each state. The initial 1 or 2 years, there may be some time it will take to catch up, but thereafter it's going to have a virally it's going to spread, mainly because it is in the hands of people now. For many categories of customers, this has already found solar PV today is already achieved parity. For the utility, in their pooled cost of power purchase, it may still be a rupee or 2 extra. But for a customer like all of us who consume more than Delhi case, if you consume more than 800 units, people pay about 9 rupees today. And in kilowatt scale PV without battery today can give you electricity below 7 rupees. without any subsidy, no support from the government. So that 7 will remain at 7. Even if you take some annual degradation and all that, it may still be somewhere around 7 to 8 rupees after 10 years. But that 9 rupee after 10 years will be anybody's guess. It will be 15 rupees or 20 rupees. So several sections of customers, solar PV has already achieved grid parity, or it is more attractive. And there is already a discussion in the government parliament that the cost of rooftop PV may be clubbed with house building loans. So if somebody is taking 10 lakhs rupees or 50 lakhs rupees for a house building loan, additional 1 lakh rupees or 2 lakhs rupees for the PV, when it is clubbed to that, you are not, and the same house building loan takes care of that. It becomes even more attractive. And this is happening. And many of you know about the Haryana order which happened this year in January. Haryana government, without even consulting the distribution company, issued an order. Every building on a 500 square yard and above should have mandatory rooftop PV of 1 kilowatt or 5% of the connected load. Haryana has few lakhs of plots which are more than 500 square yard. 500 is very small actually. So, and the existing buildings, they give a 9 months time to implement. From September onwards, they are not giving connection to any new building which is not complying with that. And the existing buildings, they have been asked to convert to that. And the Haryana order will be replicated in many other states. There are very young, enthusiastic chief ministers in many other states. It's a good thing. Actually, the whole smart grid initiative, people have been talking about the smart grid for last 10 to years, 2003 onwards, after the major power breakdown which happened in East Coast in North America. The smart grid initiative got a revival. Otherwise, in EPRI had started with the intelligent grid initiative sometime in the mid-90s, which towards the end of 90s, that was termed as expensive technology. It's good to have, no return on investment. So it's a gold technology, and they had stopped that intelligent grid initiative in sometime in 97 or 98. But 2003 it got revived. But it went on more the technology companies going and pursuing it. But in 2009, a regulator in Ontario issued a one-sentence regulation. It only said that it should be dispatched first. And how do you do that? And Ontario had some small capacity wind turbines and distributed rooftop solar. And these are distributed where utility has no visibility and no idea how much energy the wind turbines are going to generate tomorrow, how much it will the rooftop PV going to generate tomorrow, and how do you schedule it, how do you dispatch it. But the regulator made order making it mandatory that all green resources should be accommodated to the grid first before you start your other power plants and nuclear plants. And which actually 2 years people were scratching their head, but technology came to rescue. So many of the new technologies, particularly demand response, energy storage, many of the new technologies which developed in the last 5 years has origin from this one sentence regulation of Ontario. The Haryana order, I often compare to that. Yes, this is going to give a major engineering challenge to grid operators, but it will also a great business opportunity for technology companies and consulting organizations to help get this renewables, distributed renewables on the grid and operate the grid stable. Nobody has learned how higher percentage of renewables can be integrated on the grid. The discussion you hear everywhere. The problem is, all on a sudden, if the renewables disappear, how do you balance the grid? That is the traditional problem all engineers were struggling with ever since the renewables started getting importance in many geographies. 2012 and 2013, 2 years, Germany, in the peak, Germany has a lot of wind turbines, with huge amount of wind turbines, and Europe has an interconnected grid. 2006 happened, evening ramp up. Per minute, hundreds of megawatts, the ramping which happens in the evening, the load, all on a sudden wind stop blowing. And the whole grid is about to collapse. There is no energy storage, there is nothing, and it happens in the summer months when there is very little hydro in the Scandinavian area. So there are few seconds or minutes to take a decision. For RW nuclear reactor, they had to pull the graphite rod out. Otherwise, the entire European grid will collapse. That was the risk they had done. They had to repeat it 6 months down the line again. Then engineers got together and came back saying that okay, the best way to do is that we will try to start running the thermal plant as peaking plants. They have many old plants which are about to retire 5 years, 7 years down the line. They want to retire the thermal units. They said we will run it as a peaking plant. So they are running it. Initially started with bringing the PLF below 50%, 40%. Now there are many thermal units in Germany that run it below 30%. The moment it comes, below 30, 40, you need more oil support. It gives more emission. And what have you achieved on the other side by taking renewable onto the grid is lost in oil support and more emission from that. But that is for grid stability they have done. And the same thing is now some consultants from GIS who has come here, they are recommending that for India. We don't have many plants which have been used that which can ramp up and run from that scale. Or if you do that, it will run at much less efficiency and its end of life will be in a couple of years. But I'm shocked to hear that CRC reduced the PLF from down to some 59% now.
It was oil support 40%. Again, CRC is totally separate.
Allowed by law also. So, but otherwise, in places where people don't know how to even do load shedding, switching of 11 kV figure one after the other, they find it extremely difficult. So, the response technologies where you can switch off the load in a customer premise, the push of a button from the control room. That is something which is being practiced over the last 5-6 years, and there are demand response aggregators, an agency coming and signing up people. The customers are given incentives. And another latest trend is energy storage. Energy storage used to be very expensive. Last couple of years we see there are different technologies in energy storage. The batteries, grid-connected batteries, again different battery chemistries. There are compressed air technologies, flywheels, supercapacitors. There are different technologies. All of them were competing. None of them were commercially viable. But in the last 2 years we find that one particular battery technology, which is lithium-ion battery, the prices have dropped drastically. In the last 18 months it has come down by 50%. The price has come down. Mainly because it's the same chemistry cells which are used on your cell phone, which is a slightly bigger size. You use it in your laptop and other consumer electronic items, and even larger ones are used in electric vehicles, and much larger ones, megawatt scale, grid connected, or in a big aircraft. So the scalability of that, the market size which is available for them has brought the prices down, and efficiency also started going up. Today companies are willing to give guarantee of the DC to DC efficiency. Efficiencies today, lithium-ion batteries are about 96%, and they are willing to give guarantee of 10,000 cycles to 15,000 cycles, which is a fairly much longer period. So the prices are coming down. Today it is somewhere around, if you take absolute unit, it's about 14 to 15 rupees per unit of electricity when you buy from the grid, store it, and then you put it back onto the grid. It's about $400,000 per megawatt hour, the battery, pure battery, and plus the electronics which is to go for the power electronics and energy management systems which will be for that is even more expensive. Yeah, that is additional. That's per megawatt. That is somewhere around $500,000. That's about 3-4 crores even now. But the projection is that this is going to come down by another 50% in the next 2-3 years. And solar already in India it's about 4 to 5 cents in America, and in India the last big tender which you opened in Madhya Pradesh is 5 rupee 1 paise, the grid connected. So this systems with more and more renewable energy on the grid, energy storage systems, and technology to control the load at the customer premise in real time is going to be the future. And in North America, in Europe, no more thermal plants are built, mainly because there are no financiers. Nobody willing to put in money because you don't know the future of it. Asian Development Bank given over $1 billion for a railway line in Mongolia. That was to build a rail line connecting a coal mine to the nearest railway line from where it will go to the port. And about 6 years ago, when this project was appraised and this loan from ADB was sanctioned, everything looked very good, pretty good, or very good IRR, very good, because it's a very high quality coal, and coal prices in the world market was very good. And someday went up last year, the railway line is completed, and there are no buyers for coal. The price of more than 60% less than what it was estimated. And the ADB has right of the loan, they will never get the money. And it's not even like if you do the same thing in Bihar or in Tamil Nadu or somewhere, at least the railway line can be used for transporting people. In Mongolia, there are hardly any people, and it can be used only for transporting coal. So how do you future-proof your investment in this changing scenario? And it's extremely difficult to find financiers even in India for no new thermal plants. The private people have come up in the last 1 or 2 years, because one side is the started capacity, but even otherwise, 20-year life, 30-year life of a thermal unit, you don't know the future. If the electric vehicles, which will again be used as a the storage device which can pump electricity back into the grid, and I hope you know about one of the national mission is a national mission on the electric mobility with a target of 6 to 7 electric vehicles. This was announced actually 2 years ago, but there was no subsidy. There is a subsidy in the electric mobility mission. From the budget, that subsidy has not started giving. But this government this year has said that they are committed to do that. From the next budget, there will be subsidy for buying cars. The electric cars which will be available will be more cheaper. And they intend to make charging infrastructure, particularly for public transportation, which is going to happen very soon. So many of the things which I am talking about, more generation capacity adding at the distribution and the traditional boundaries between generation, transmission, distribution fast disappearing, and the grid evolving as an integrated grid, energy storage becoming commercially viable, and you will find more and more energy storage added to the grid. In California, the regulator has made it mandatory. 3 large investor-owned utilities there, PG, Southern California, Edison, and San Diego Gas and Electric Board. They have been mandated to put in 200 megawatt of energy storage by law last year, and they are commissioning it sometime end of this year or next year. So the same way, more and more regulators will mandate these kind of measures on the grid. And this change which is going to happen is not distant dream, although we are grappling with our mundane issues of access to electricity, grid free from power cuts, relief from DSM, these kind of issues, or reducing that transmission distribution losses. These are problems which government policymakers are today really hustling around. But this change is happening. 10 years ago, if somebody had told that every man on the street will have a cell phone in his pocket, nobody would have believed it. A video phone as a technology, AT&T came out sometime in 1963 or 64. But it was not big that nobody was using a video call. Last 3 years, 4 years, without paying any money, you can use fiber and now one support. So you can do a video call from anywhere to anywhere in the world. The pace in which technology is changing is much faster than in the past. I would say 15 years of 21st century has seen more technological advancement than the previous 50 years which we have seen. And now more and more of inventions are done by machines, not by human brain. There is a prediction by Professor Kurzweil had predicted that singularity will happen in 2040 plus minus 5 years. Singularity is the point when the robots will have more intelligence than human beings. But today it looks like it will happen in 10 years. There's already robots doing several jobs which human beings are doing. In Chile, in Nagasaki, a hotel is commissioned in Japan, in Nagasaki. It has 80 robots and 10 human beings in the control room. Everything from check-in point to room service to restaurant, everything is managed by robots. As a guest, if you go stay there and come out, you will never see other guest only you will see. Hotel management, you will not come across a man. They are in the back room. And there are restaurants in China. You go to the table, there's an iPad, you order food, and food is served to you by a robot who speaks any language. You speak English, he will reply you in English. You speak Hindi, he will reply you in Hindi. Because it's additional one more language which is programmed into it. And those robots, a company in China are selling at $3,800. $100 for every additional language. And 10 years down the line, if I say that many of the restaurants in Delhi will have robots serving it, hotel owners will invest because he will work 3 shift or 4 shift, 365 days. Or the time required is charging. That also he himself will go and charge and come back, or swap the battery and come back. And he will not sweat, he will not smell, and you don't pay overtime. And so, as a customer, you will be happy to be served by a human being who can smell. And that is going to take.
The food, sir? Who prepares the food?
There are robots also, but that is not popular yet. That is not popular yet. That may be 20 years down the line. That may be 30 years down the line. 30 years down the line. And autonomous cars. You today see autonomous cars driving. I've been seeing it for last 5-6 years on 101 highway 101 in California. Google been running it. About 2009 or 8 when I saw first time autonomous car going center. There are 4 cars, 2 on the side and 2 on the back, with all wired up and taking it. So today it runs without anybody in many places, and in another 5 years, 10 years down the line, you will see autonomous cars everywhere. And these two, I won't, in the interest of time, I won't get into more and more of this technological changes which are taking place. The robots and autonomous cars alone going to take away millions and millions of jobs from human beings, poorly skilled human beings. Today, our policymakers, political leaders go and thumb their chest saying that I have 600 million Navajavan below the age of 30. What will they do? 90% of them have no skills other than some of these menial jobs, which will be machines very soon. And what is the impact of long-term impact of these technologies which are changing at faster pace year after year on society, on culture, on economics? It's a very, very important topic which needs deliberation at every level, from the working man level all the way up to the leaders of the nations. Here again, I am an optimist on technology. Technology will find solutions. I started my career just across in Nehru Place. Those days there were very few companies in Nehru Place. Early 1980s, when we walked around there during lunch time, all bank employees used to sit on the plaza, main plaza in Nehru Place. All India bank employees, hundreds of people will sit against computerization. This is mid 1980s. They all said that we will lose our job. We don't want computerization in bank. So you people should come and give a check, and Abhishek may not even have done that in your life. So you go give a check to the clerk, he'll give a metallic token, you put it in your pocket and stand there, and the cashier will call out. Later he had a electronic thing, your token number will be displayed, you go take cash. That's the way we lived. Well, there was progress for humanity that time also. But now, how many of you ever visited your bank? Rarely when you get a check, you send somebody to deposit. Otherwise, everything, you get 24/7 money everywhere. Life has become more comfortable. Today in India, there are more bank employees than that you were there in, maybe several times more bank employees in India today than in 1980s. So the same way, we may have more and more systems, more and more avenues of recreation or economic activities, going to space, coming back, all those things we may do. But this things are imminent. It's going to happen. The cars which are going to be driven automatically. You may not even own a car. You just ask for it. You get a car. It will take you where you want to go. And this is going to happen in India also in very short time. And the grid, energy efficiency, the smart grid, all these things which are going to be real. And I'll make 3-4 things which the government has done on the smart grid part. In 2013, we came out with a national program for smart grids, how to transform the grid into a completely intelligent grid which will have resiliency, giving electricity to all the citizens. That's a 15-year roadmap which Minister of Power approved. And while finalizing that roadmap, there were a host of stakeholders who consulted. Everybody said the best vehicle for achieving that is not a program like RFP, which was a government program. Don't do it as a program or a project of Government of India, but do it as a mission, like national missions, where all stakeholders will have participation. and more work in any case need to be done in the states by the DISCOMs and the transports and all that. So a national smart grid mission was proposed in 2014, which the previous government had supported it, and the new government has approved it in March this year, the national smart grid mission. And under the mission, some projects will be announced next week. And it's again going to be dovetailed with several other government programs like the Smart Cities Mission. So out of 98 cities, out of 198 has identified 2 in Jammu and Kashmir said to be finalized, which are those 2 in J&K. Out of the 98 cities, Ministry of Power under NSDM proposed to implement smart grid in 30 of them and will give 30% grant. And the first 7 projects will be announced until next week. And another very important thing which we have done, in 2013 when Government of India issued the smart grid roadmap, we were the 6th or 7th country in the world which had a national smart grid roadmap. The mission, we are only one which is having a national mission approved by the cabinet which is doing it. The only other country which has a legislation for smart grid is South Korea, which they did it in 2009 or 2010. Another very important piece of legislation which you have achieved is Forum of Regulators have approved a model smart grid regulation in June this year, and they have already notified it. And according to that, every SCRC need to come out with a state-specific smart grid policy. And sir, with your support, it was Maharashtra which started with a smart grid consultation committee and smart grid policies for Maharashtra, which after you left, there is a what you call loss of speed in many of the new policies and programs in Maharashtra, which I am sure maybe by end of this year, the specific policy which were prepared that time in 2013, 2012 will finally become a Maharashtra government policy for smart grids, which is ready. Document is ready. This time itself it was almost final. Assam and Karnataka are 2 states which have already notified their draft smart grid regulations. Every other states will do. In 2013, when Andhra Pradesh and Tamil Nadu came out with net metering policy, every other state was asking, why do we need it? Why do we need it? Andhra has reissued. There were flaws in the first net metering policy. Today there are 23 states, including Delhi, has net metering policies. It happened in a span of 2 years. The same way, by end of next year, almost all major states will have smart grid regulations in place, and many of the projects under National Smart Grid Mission need regulatory support, demand response to disconnect load in the customer premises, utility control room, which today you need a 50 days notice. We need regulatory support for that. Time of use pricing, which we need regulatory support for, a host of other things regulatory support. So this is going to take. The last thing which I'd like to mention is that this is again a major achievement. We issued, Bureau of Indian Standards issued a smart meter standard. It's a low-cost indigenous smart meter standard issued by Bureau of Indian Standards in August this year. That's also a major step towards having interoperability at meter level itself. And this is again, you will hear anywhere, the government has decided to come out with an announcement that in the first phase, all customers who have 500 units per month electricity consumption will be converted to smart meters in the first phase. That will happen in the next 2-3 years, and the next phase will bring that down to 200 units. So this is the ministry has already decided, some appropriate for either minister or prime minister will announce, but this is already session taken. So this 500 plus 200 two phase, it is going to be somewhere around 150 million customers. About 15 more customers will be fitted with smart meters in the next 5 to 7 years. It's going to be a very, very major transformation.
My name is Koshi Charail. I'm president of the Alliance for an Energy Efficient Economy. I have the opportunity to stand before you because one of our board members is Dr. Mahesh Patankar, who is known to RCMS, and he was unable to come and ask me if I could represent, and I'm more than happy to do that. Also, it's a really a big honor to share the dais with Varmaji, who I've been following right from the days he was in CA, then Bureau of Energy Efficiency and CRC. And I remember the time when we were scaling up, you were there, sir, and you were leading and giving it a lot of boost at that time. And Mr. Rajiv Pillai, I've known him right from his IBM days in the utility sector, and as always, his description and the optimism that he paints about, it's not painting, it really portrays about Indian energy sector is really very, very heartening. And broadly, I would like to point out that Mahesh's overall theme is that energy saving technologies keep improving faster than they are applied. So more than ever, energy efficiency is even larger and a cheaper resource we have. Let me just open the presentation. And first of all, a big thank you to Rachna Management Consultancy and Studies, because you really have a very well-packed 3-day workshop and covering practically all aspects of electricity and energy management. It's really, as you shared your agenda with me earlier, it was really very, very informative, and I'm really happy that a wide variety of organizations and experts are gathered here. And I hope this insight into the energy efficiency part of it would really complement that. I don't think information here is anything very new to you, but what Mahesh has done is to organize them in a very systematic way. And I have a few copies in hard print, and I'm sure they'll share the soft copy also. So I just brought it along in case you may want to refer to it. The information and the way he has portrayed the energy efficiency, particularly the legislation, the changes over the years, is really very useful for anybody, even as a background reference, and to understand how the sector has moved. As Mr. Pillai mentioned yesterday, we both were at a forum where Alliance, AEEE and FICCI organized on behalf of Niti Aayog, formerly Planning Commission, to put in a component of energy policy on the energy efficiency side in the energy policy, which is being prepared as India's response to the COP next December. And it is really significant that over the years, energy efficiency is also being considered as a major measure, major step, and a major component of national energy policy. Because, as was mentioned by Mr. Pillai, the time when we just manage load and manage demand is over, or we cannot afford to neglect that. It is balancing efficiency, balancing the end-use side of the meter that is most significant. Mahesh, the author of the paper, has presented India's power scenario, and totally its installed capacity of 275 gigawatts in India. And then, of which even now 70% is based on oil, coal, and gas, fossil fuels. Now, however we have been able to manage demand and supply, the demand has been constantly growing. Developmental needs, industrial growth, transportation needs, the demand has been growing very steadily. And the peak energy load is 1.41 GW, and the deficit is 4.7. So also the energy deficit is 3.6. And while we've been incentivizing alternative energy, the need for it is felt even more now today than ever before. Can we consider energy and conservation as a resource? Actually, it's called the resource of first use, the first resource we can draw up first. And as you know, when you think of generation, you need twice as many units to resources to generate power than to conserve. 1 unit of electricity to conserve. But even then, there are unexploited market opportunities because of the failure of the market to bring in efficiency by its own nature. And here again, this is the one area where international cooperation can benefit a lot, because the advances made internationally is far more than what we have been able to integrate or do it ourselves. And it's a fact that India has been also leading in this area in terms of innovation and adoption. Now, the legal framework, which again many of you are from the regulatory sector, it's well known, but in the energy efficiency side, before the 2003 Electricity Act, the background to it was that there were 3 acts: the Indian Electricity Act 1910, the Electricity Supply Act of 1948, and then the Electricity Regulatory Commission Act 1919, after which the regulatory commissions were set up. it has been portrayed here very clearly. I wouldn't go into the details. The main feature of the 2003 Electrical Act is to clarify the role of the government and also give an emphasis on rural electrification and the division or the disaggregation between generation, transmission, distribution. The matter of consumer protection, consumer not just as a source of demand and to satisfy the demand, but also as a responding and an active participant in the process. And the process of trading and marketing of power and energy. Then, of course, the regulatory commission and how does one appeal in terms of issues that are presented by the commission and to the commission. Guidelines regarding tariffs, and then the Central Electricity Authority and its various mandates. Then theft of electricity, which was increasingly draining us of not only resources but also increasing the inefficiency. And then the various state electricity board restructuring plan. Now that was the background on the Electricity Act side. In 2001, the Energy Conservation Act was passed, and which led to the setting up of the Bureau of Energy Efficiency and the various initially voluntary but gradually being mandatory various provisions. Now the next big landmark was the 2010 set of amendments, which we are coming to very shortly. In each of these, the role of demand side management, that means looking at the demand side of it, the other side of the meter, has been portrayed very clearly in right from 2000, each of the various acts and where it's included. This is a very useful reference. I hope you will go through it in detail. And moreover, even the role of efficiency in terms of coordination and distribution systems is also elaborated very clearly. And energy efficiency and conservation, particularly from the demand DSM approach, the demand side management approach, where interventions are made on the consumer side of the meter. And moreover, can we really, only very recently we understood that the demand can be really modified to match with supply and also to meet the end use and to maintain a certain level of stability in the grid as well as the power supply. And moreover, is it possible, like we talked in terms of demand response, to have a partnership between the utility and the customer? Now, DSM has multiple benefits. One, directly to the customer, he gets more reliable services, possible reduction in tariffs, and improved value of service, and also to maintain improved lifestyle and productivity. The broad social benefits is that there is a reduction in pollution, and you conserve resources and be a partner in global environment management, and of course allow more power to the needy segments of the society. The utility itself, again, it lowers its cost of service and brings in efficiency in their operations and reduces the need for setting up more power plants, and then makes them more accountable and responsive to customer needs. Now, 2008, the government announced the National Mission on Enhanced Energy Efficiency, which again integrates multiple missions which have involvement of various different ministries and organizations. Of the main 8 missions, we have the National Mission on Enhanced Energy Efficiency, which again includes a lot of different sectors and different missions. We have the Ministry of Housing in terms of buildings management. We have the Ministry of Power, various Ministry of Renewables. All have been have a role to play in this, and also to create a kind of a conducive macro regulatory and policy regime. Moreover, to involve businesses and get an active participation of business into the energy efficiency activities. The goals of NFEE is market-based approaches to unlock energy efficiency opportunities, which was estimated to be about 74,000 crores when the mission was announced, and also to achieve efficiency in implementation. The following an annual fuel saving in excess of 23 million tons of oil equivalent, and cumulative avoided electricity capacity addition of 19,000 megawatts, and a CO2 emission mitigation of 19 million tons per year. These were the NFEE objectives. Now, within them, especially those affecting the electricity end use, are the perform, achieve and trade scheme of the government, where the energy efficiency of energy-intensive industries is the focus. And the concept of trading energy savings and eventually having a kind of a stock market scenario in the energy efficiency side. Now, the one in the renewable energy and even emission trading have already been evolving in other parts of India, but this is one concept which is increasingly getting accepted. I would just like to mention that AAA, in partnership with one of our members, Sustainability Outlook, is bringing out a quarterly brief on PAT program, how, especially now that we are moving into the second cycle, the industry is responding to it. Please do write to us, we'll be able to share it with you. There's more details on PAT in the later segment. Now, another component of the NMEE is the market transformation for energy efficiency. And here, how do we manage a shift from in the appliances segment, household appliances, appliances which help us modify the environment, air conditioning, and various appliances of home use. Under this comes the standards and labeling program of the government. We are announcing various products which have to meet 5-star mandatory 5-star standards. At the same time, it's not enough just to label products. How do you increase the offtake of these products in the market? Then finance is very critical in energy efficiency. Therefore, the third aspect of NMEE is the energy efficiency financing platform. And again, this could be a mechanism for financing demand-side management, besides what goes on from the kind of regulatory commission mandates which require utilities to spend on demand-side management. Moreover, there are now three components which are active now. The partial risk guarantee fund, which ESL and SIDBI would be managing. So also the partial risk sharing facility, which is again to increase the ESCO role in the energy efficiency, energy management system. Once again, the partial risk guarantee was initially targeted at the government buildings, municipalities, wherever public sector institutions were involved. But now it's been widened to include private sector also. And this is a kind of loan protection which allows banks and private financing entities to invest in energy efficiency, to secure the last mile of it, the last segment of their investment from a pause in case there's a default in the loan taken by an ESCO, energy service company. So also giving fiscal instruments and incentives for increasing energy efficiency. Now, what is unique is that regulatory commissions can mandate demand-side management targets to the utilities. But AAA has been working with many of the energy service companies ready to end customer of DSM, but all potential for energy efficiency. It could be industrial clusters, it could be large hospitals or commercial complexes, institutions where the potential is very high. And because of the metered relationship that is there with the end user, it's much easier for an ESCO, energy service company, to identify savings and realize the potential and to earn their revenue. Because there's already a metered relationship between the utility and the end customer. This is one area where AAA had worked with PSCS, Yamuna Power in Delhi and Tata Power in Delhi. Also, companies such as Godrej and Wipro Eco Energy were ready to partner with these utilities in realizing energy efficiency. Incidentally, one model that is emerging and which has been tried out globally is, can a utility either set up its own ESCO division, ESCO group, or can a utility partner with an ESCO to reach out and do that? In Delhi, the NDPL Infra was one of the financing arms set up by Tata Power, and Tata Power itself is registered as an ESCO. But there are many challenges in this, because it's like having a utility tell its own best customers don't buy our electricity. It's always a challenge. At the same time, their concern is more the inefficient users, the users who do not pay the utility bills. So these are the various emerging models that are coming about. Now, I had just mentioned about the Perform Achieve Trade Scheme. There are 8 sectors which include aluminium, cement, chlor-alkali, fertilizer, iron and steel, pulp and paper, thermal power and textiles. Now, what is interesting in this is there are some of these sectors which are largely in the public sector. For example, fertilizer, there are only 4 or 5 units which are there, and they are all public sector. much of power generation, thermal plants also come under public sector management, whereas the number of units in the others, particularly textiles, pulp and paper, iron and steel, so number of units are vast and it's very dispersed also. So managing or forcing energy efficiency, or hand-holding them in energy efficiency is always a challenge. And that's where the private sector involvement, involvement of ESCOs are very, very important. Again, we have the example that the cement sector is in India is one of the most efficient, even in terms of global standards. But that's not alone. There are also a lot of inefficient cement units, cement plants. So even among the 478 identified high-intensity consumers, where the government program is being run, there are various mixes, and again the issues of how do we quantify energy savings within each of these, how is the reporting to be done. These are the challenges there. And 2014-15, the first cycle of PAT, 3 years of the first in a way an experimentation was completed. Mixed results, very much of learning, and the government is making use of the learning to really make the second cycle much more useful and responsive. In addition, the government has added 3 more sectors: power distribution, the list is there, I'll go through it. But and also, moreover, the challenges was that the designated consumers were mandated to reduce their specific energy consumption, energy used per unit of production. And also, this was based on the current energy efficiency standards, energy consumption. And based on the previous consumption, the previous 3 years, the baselines were determined for these designated consumers. And overall, a reduction of around 4% in these units for what was possible, achievable. But this helped in total energy saving of 6.6 million tons of oil equivalent by the end of the first cycle. Now, the energy saving certificate, which are known as e-certs for short, has been issued to the designated consumers who have achieved savings beyond a set target. On the other hand, those who fail to achieve, these e-certs can be purchased by them to avoid penalties, or as a way of keeping up with the more efficient units. Now, how the trading goes, how will the demand and supply work, that is something that we are still learning from, the government is still learning from that process. Now, in the subsequent cycle, as I mentioned, the second cycle, which is from 2014 to 2016-17, railways, tuition, where discounts come in, and the oil refineries, these are also included. And now, if these sectors are completely covered and all the large units are covered, then about half the commercial energy consumed in India will be within this scheme, and we'll be able to achieve targets that are set up on a uniform manner. This slide shows how DSM has evolved. The best landmark is the latest 2010 to 2014. Then there are 16 states who have finally notified DSM regulations. So, and moreover, there are a lot of efforts made by the government to provide information on the regulators, to review their plans and give them guidance on these. It's definitely a challenge because demand-side management requires a lot of divergent skills in the utilities. The utilities are geared to supply electricity, to avoid shutdown, to minimize load shedding. So on top of it, when you overlay a set of orders which says you supply more efficiently and manage the demand, it's really a lot of change in mindset is required. And there are a lot of good examples, which can be shared and learned from. And this is where, especially comparing the efforts and achievements or even failures of private sector distribution companies and public sector will always be a benefit. And when we look at the different states, this map shows that out of the 16 states, the central belt, which runs from northwest to southeast, is still to be mandated. Of course, these states have unique challenges, and they have also launched the DSM programs. And again, it is not just DSM alone. The combination of strategic conservation and load management programs are at work in these states. And these need to be scaled up, and this is not yet achieved, except that in terms of lighting efficiency, one of the ESL, which is the commercial arm of Bureau of Energy Efficiency, has done significant initiatives in terms of replacing conventional lighting, especially in street lighting, with LEDs. And HFP was involved in developing the MNV application guide for this, because it's one thing to do the replacement, but another to really record savings and monitor the achievements that are done, and learning from best practices at one place and being able to share and avoiding the mistakes of this program. I think it will be really good. I understand Mr. Savar Kumar will be here later in the day, and it will be really good to hear from him the role that ESL has played. And that's not the only thing ESL has been designed for. They have targets for improving, supporting PAT program by working with the designated consumers and other industrial clients. There are also programs to strengthen the ESCO energy service companies to do performance guaranteed energy saving programs. Now, this gives a more clearer detail of the energy efficiency achieved under the one example of the ESL street lighting program. I wouldn't go into details. I'm sure the presentation will be available. A few copies I can share in hard print. Now, one of the programs which the author Mahesh presents is Tata Power's commercial standards of program, which is implemented directly by the utility and without a kind of a middle aggregating agency. Here, HVAC load, lighting, motive power and control systems were also introduced. Measurement and verification was a significant part of it, because any project, any experiment done in energy efficiency has to be monitored and recorded and really chronicled properly so that you are able to quantify that. Then the standard operating procedures, a price of 1 rupee per kilowatt for verified savings was decided, and time duration is 8 AM to 8 PM excluding Sundays and weekdays. This is one of the examples which could be cited for demand side management. In essence, as the thread running through the discussions here is that energy saving technologies keep on improving much faster than they are really applied. So efficiency is an ever larger and a cheaper resource. And as you see, the simplest example would be incandescent to tube lights to CFLs to LEDs. So both even to introduce renewables to the grid, which is a major challenge, as Mr. Pillai pointed out today, unless efficiency also keeps up, then the application of renewables become much more meaningful and will be able to play a better role. Thank you once again. If there are any questions, wherever I can answer, I'll do that. Otherwise, I will direct them to the author, Mr. Mahesh Patankar, and I'm sure he'll respond to you by mail if it's a one-to-one. Thank you very much.
We started the energy efficiency program to save electricity when we were very short of electricity. Today we are not. We are not short of electricity. The shortages which appear in reporting of the CEA, the government and all, these are of different kind of shortages. Except the southern region, where there is some transmission problem is there, the shortages which are appearing, all those shortages where the electricity is not supplied in UP, Gurgaon, here and there, they are different kind. The distribution companies have no money to buy power. This is one. There is theft of electricity. I don't like to charge this conductor, because the moment I charge, the theft starts. I don't get. The distribution company, the more they generate and distribute, more they lose, because on every unit there is a loss of 1 rupee to 2 rupees depending on the various states, etc. So that is one reason. But generally, adopting the energy efficiency measures would result in saving of the fuel. We have a scarcity of fuel. Our fuel is really not able to keep pace with the demand, etc. And therefore, in any case, the carbon dioxide footprint could improve if we have energy efficiency plants and if we generate the power at higher efficiency. This is a very installed capacity is more, and then our generation, the peak power demand is less. One is that we should not directly link up with this. We have say 270,000 megawatt of installed capacity, out of which 35 to 40,000 megawatt you remove. This is renewable. So it is only some 230,000 megawatt. And for any system, universally, if you want 1,000 megawatt of power, you must have an installed capacity by way of thumb rule, 1,300 megawatt of power you must have. So if our demand is 1,50,000 megawatt, so at least the capacity you must have is 2 lakh megawatt. So 30,000 megawatt capacity, which appears to be surplus, they are not generating because of various reasons. These 30,000 megawatt capacity is shut down because of the costly fuel. People don't demand. Power is not requisitioned. Like naphtha and Kayam Tulam of NTPC and others, they are not operating. Similarly, our gas-fired stations, gas is not available. The gas-fired capacity is running at 30% or even low PLF. That is the capacity which is not generating. And the new developer must think about it before investing in the new plant. After all, the electricity will be sold only to demand. Suppose we install 50,000 megawatt capacity more today, as the plan is going on, and if the demand is not increasing, this will be a stranded asset absolutely, unless you compete and sell, able to generate power at the competitive price, so that your power is chosen and the others are shut down. So state stations are going to suffer in future because they will be costly power. For example, Haryana plants are not generating. They are buying power from Adani here and there because it's a cheap power. So many states are going to suffer that scenario unless they improve efficiency of generation, inefficiency of the distribution company, etc. That point has to be taken.
So actually the problem is, the states like Delhi, which are in surplus of power because they have a long-term power purchase agreement, and when they sell this surplus power in exchange, they get additional loss over it. So when a distribution company comes with a demand-side management program, you will more save energy, and actually the energy saved will be sold into the exchange at a lower cost, which will actually increase the regulatory asset. So that are the little bit issues which we need to tackle. And
these issues are specific to Delhi because I remember that before these games were, CA did project that the demand of Delhi is not going to increase beyond 5,000 megawatt at that point of time. But somehow the ministry was overcautious and they contracted Jarjar and here and there. It was very expensive power. And that kind of a scenario and the environment was not existing at that time. And the Delhi company was selling power to J&K and all. But it was something is better than nothing, something like that. So, and then I remember that the DVC power was reversed. You contracted some 300, 400 megawatt from DVC. And I was requesting Delhi that at least negotiate with DVC, tell them that they could allocate this power to someone else, and that was done. So many such actions are required, maybe even in today's context. You have to discuss, deliberate and find out, maybe you help NTPC or something to find out their own customers, and so that you don't get, but if everybody acts in that manner that we buy only cheap power, then who will buy the expensive power? So it has to be, this game has to go on. It is a commercial arrangement which you have.
We had a 15-minute tea break in between, which I had not seen. Sorry. So now we have 15 minutes.
But one thing is very clear. You see, per capita consumption yesterday it was projected to be 700, but it is around 1,000 units today. The immediate CA works out, and then therefore, but per capita consumption is not increased just by increasing the generating capacity. You have to increase industrialization. You have to increase the living standards, the rural area. And everyone has to have the modern gadgets in their houses, right? But then only the per capita consumption increases. Not just like that. I remember Bihar was arguing when we were making the 17th power survey in CA, and we were showing every state's demand, etc., region-wise. And Bihar was very annoyed that why are you showing low demand from Bihar? Then I said, we will agree to your, you please agree to our demand. We will see for 1 or 2 more years if your demand is increasing and if you are, what are your programs of industrialization, which industries are coming. They were not able to project. But everyone thinks that just by installing power stations per capita consumption can increase, it will not increase.
So take 2 minutes to wind up commercial development. We failed in 70 years in giving electricity to all the people. The models of electrification which we pursued, millions of dollars invested, we could not achieve what we intended. Just outside Patna, 40 kilometers. Yesterday, one boy was with me. He is a highly qualified double PhD boy working in Bangalore, but his own village is 40 kilometers outside Patna city. Even today, they have no electricity. I was telling him, the world's largest off-grid solar market is Exhibition Road in Patna. 1.2 kilometer road. So the 100 watt, 200 watt kind of 40 watt kind of packet. You can go fix up everything. Are sold. $100 million was 2014 turnover in that 1.2 kilometer road. Who are the people who are coming? They have traveled overnight or from very far away villages and come by. They don't know anything. I mean, no standard, nothing, and they don't know what to buy. Anything from 2,000 rupees to 7,000 rupees they can buy, and they take it. Why? Because we couldn't give grid power. And also today I am told that in Jharkhand and Bihar and all those places, in the dowry list, one of the top item after bicycle, number 2 is solar light. And that is why the people come to buy that. So we need to have a much bigger discussion and debate with people who actually run the ministries to come about on that. And another very important point we would like to discuss is that we talked about several parallel programs happening this week. One of them is on low voltage DC. So BIS along with IEC running an international conference on LVDC, low voltage DC. I talked about more and more generation resources getting added at the distribution end in the beginning. But another very important thing which you are consciously not noticing is that in your office and homes, more and more power consumption are consumed by devices using DC. All the TVs are DC, your computers are using DC, your phones are DC, more and more devices are using DC. And many communities today, a sizable percentage of the consumption is in DC. And many of those campuses and buildings which are also having rooftop where you generate directly in DC and you convert that into AC, distribute into DC, and again you convert it back. Almost 60 to 70% is lost in that process. So the concept of direct DC distribution systems. 2, one in urban areas where you can have a parallel DC. I mean, some of the hotels are already doing it. You have a USB. Many of the hotel rooms today are doing it. Professor Ashok Jindwala in Madras IIT, he has done that. He has also, with the Corporation for the Industry, he has developed LVDC fans. He has, his one office block is completely on DC. His house in IIT campus is completely on DC. And he been pushing that idea across the country. And another small companies, there are many small companies which are around the remote areas through CSR money and all that. One very important one is that 120 houses in somewhere in Orissa, the nearest civilization is 300 kilometers away. They have commissioned that in August. A small bifloor-based company called Sanmoksha. Some company has given them some 60 lakhs rupees or on CSR money. And this 120, 130 houses, and not only they have made a community center, water pumping, all those kind of stuff, completely DC, and it can be monitored from outside. So then never we will have a business case to take a grid that 300 kilometers away to give that 120 or 130 houses electricity. So DC is both off-grid DC grids and also grid connected or parallel DC grids, which is an area which is taking place. And lastly, another very important tool which we developed, the Government of India Planning Commission to IESS, I don't know how many of you heard of it, Indian Energy Scenarios. It's a simulation tool. 50 years down the line, they started doing it in 2012 for 2052, but finally when they launched, they wanted to do it 2047, IESS 2047. If you Google, you will see it's a carbon calculator. It help you model different scenario, whether you have to actually convert electrification, transportation to electrify, or you continue the same way. How much percentage of renewable should be in a smart city or in conventional existing cities? What would be the effect on the total emission? That tool is a very good tool which was launched in February 14, which the second version, the much more modified, better version, launched this year in August. IESS 2047, if you Google, you will find it. It's a free tool which everybody can do. You are not thinking you can use it. People should use that tool. So thank you very much, sir.